Welcome guys to the next installment of the Trading Psychology and Mindset series. So far we have discussed the basic framework of the markets, how one should view an individual trade, and the habits of a successful trader. The next two videos will deal with mathematical concepts that are absolutely essential to master if you want to be a good trader. You don't even have to go into the exact numbers. You simply have to have an intuitive idea for these concepts because that will help you adapt your habits to be a successful trader. The first concept is called conditional probability. I assume at this point you guys all know what probability means. It means the likelihood of a certain event happening if we had a large enough sample size. For one common example is if you flip a coin, the probability of it being heads is 50%, the probability of it being tails is 50%. So let's see what conditional probability is. In a universe, let's say whatever experiment we are doing, we might have a certain number of possibilities, which is called the universe of possibilities of that experiment. If we put a condition on that universe, then the number of possibilities reduce. I'll give certain examples to show what that means. Let's say you have a deck of cards, you have 52 cards, and you will calculate the probability of picking out an ace. So that would be 4 divided by 52, that's 1 by 13. Now, let's say I put a condition. I put a condition that I've already taken out a card from the deck that was an ace. Now, what's the probability of the next card being ace if I pull it out from the deck? In this case, based on the first event, the number of possibilities reduced because we only have 3 aces left in a deck of 51 cards. And the probability of picking out an ace now is 3 divided by 51, that's 1 out of 17. So you can see how putting one condition changed the odds, and that's what conditional probability is. Another example, let's say you have a crazy friend who decided to play Russian roulette. He puts a bullet in one of the chambers and the gun can have 6 bullets total. So he puts 1 bullet and the other 5 chambers are empty. He spins the chamber and shoots. The gun comes out to be a click. The chance of that first shot killing him was 1 out of 6. Now he throws the gun towards you, and if you shoot, the chance of the gun killing you is 1 out of 5, right? Because you already know that one of the chambers was empty, the one that he shot. So the bullet has to be in one of the remaining 5 chambers, and your odds of dying just increased to 1 out of 5. So you can see based on the condition that the first shot did not go off, the probability of the second shot going off increased. And again, a condition, we put the first condition that the first one didn't go off and changed the odds of the next event. That's what conditional probability is. I hope you are starting to get this idea. The basic idea is that as we get more information, the odds change and we have to adapt with that. So let's go into some of the mathematics behind this. For those who are not mathematically inclined, it doesn't matter. I will try to simplify it as much as possible. But this is the core theorem of probability. Think of how you have Pythagoras theorem for geometry. Bayes theorem is the core foundation of probability. So let's say we have this universe called U. That's all the possibilities that are available. You have a set of event called A and you have B. And then there's an intersection where you have A and B happening at the same time. Now, if you want to calculate the probability of A happening, given that B already happened, So this A slash B means probability of A given that B happened equal to. Now in the denominator, because we already know the condition that B already happened, our universe went down from this entire thing to just B. So in the denominator, we'll have probability of B happening. In the numerator, we will have the intersection of A and B. Because we are calculating the probability that of A given that B already happened, that will only happen in this area, the yellow area. So the probability of A intersection B divided by PB, probability of B happening, is our conditional probability. This should make intuitive sense. Our universe went down to just the probability of B, right? Our universe went down to the events happening in B, and then what we're trying to calculate is A happened, given that B happened, is both of them have to happen, so that's in the numerator. Now similarly, probability of B given A, it would be P A intersection B divided by PA. And just some mathematical movement, we have PA intersection B equals to PB given A multiplied by PA. And we plug that into the first equation and we get this, which is the Bayes theorem. PA given B equals to PB given A multiplied by PA divided by PB. Now you guys, math aside, you guys might be asking, why is this important? Why are we playing around this way? We are playing around this way is because in real world, based on historical data, it is possible to calculate one of the conditions, one of the conditional probabilities. I'll take a real world example so you have an idea of what the hell I'm talking about. Let's say the condition A is a fatal heart condition and condition B is a person is 70-year-old. So let's say I'm 70-year-old and I go to the doctor and I ask him, like, what's the probability that I have a fatal heart condition? Now you should intuitively know that your age matters in heart conditions. So that's why we're giving a conditional probability. We know the condition that I'm 70 years old. What's the probability that I have a fatal heart condition? Let's see what's on the right side. On the right side, we have probability B given A. That's probability that the person is 70 years old given that they have a fatal heart condition. Now in real world, you would have data on people who get heart conditions, and that data would be distributed based on age. So you can easily find the probability that of a person being 70 years old given that they have a fatal heart condition, right? That can be calculated based on historical data. You multiply that by the total number of people that do get heart conditions, and then you divide it by the probability of a person being 70 years old, right? We reduce the universe to the person being 70 years old because that was my first condition. I'm 70 years old. And on the top, we get the probability that we have a person has a fatal heart condition multiplied by that the person is 70 years old given that he has a fatal heart condition. So you guys saw that based on real world data, we might be able to calculate one of the conditional probabilities, and that helps to get the other side. Now you don't have to do any of this in trading. I just wanted to throw out Bayes theorem in case you were interested because it is important. What I want you to see is first of all, the practical side of this, and then the second is the mindset shift. You won't really need to go into the details of conditional probability. It's more about the mindset change that's needed. So let's go into simpler examples and games because that's what market is. It's a game. Okay, this is another Russian roulette example, and this is a bit counterintuitive one. So listen closely. Again, you have that crazy friend. This time he put 2 bullets in out of 6 positions. So we have 2 bullets that are filled and 4 that are empty. He spins the chamber and then shoots. So our B condition is that the first shot didn't fire. That's our condition. What's the probability that the second shot won't fire? So probability of B that the first shot did not fire is 4 out of 6, 2 out of 3. That's the universe we have narrowed down our possibilities to. Probability of A intersection B, that both shots don't fire, that's 3 out of 6. How? Let's see. Let's say assume this is chamber 1. So we have 2, 3, 4, 5, 6. So the fact that the first and the second shot won't fire would only happen in these cases. 2, 3, 3, 4, and 4, 5. Out of 6 total possibilities, which are 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, and 6, 1. So the fact that both shots don't fire is only possible in 3 out of 6 scenarios, which is half. So we calculate the probability that the second shot doesn't fire, given that the first one did not fire, to be half divided by 2 by 3, that's 3 by 4. Now, why is this counterintuitive? It shows that, let's assume the first shot, if you didn't have this condition, the first shot didn't fire. In that case, the probability that the second one doesn't fire is only 2 out of 3, right? For example, like after the first shot, you just spin the chamber, so it's completely random. Your second shot doesn't firing possibility is 2 out of 3. But if you do not spin the chamber again, and you use this condition that the first shot did not fire, the probability of you being alive increases from 2 out of 3 to 3 out of 4. You see how it's counterintuitive, because in the first example we took in slide 2, where we only had 1 bullet, your probability of dying increased. In this case, your probability of living increased based on the condition that we were given. And this is why conditional probability is important, or being just trying to use probability in making decisions, because sometimes you might get a counterintuitive answer which might just save your life if you have crazy friends. All right, now let's get all of this back to the markets and connect the pieces together. Where does conditional probability come in play, and how should we change our mindset to account for it? The clear-cut example is failed breakouts and breakdowns. Let's say this is a solid resistance, right? And price has been coming and getting rejected a bunch of times. So once price breaks out of it, our probability of being bullish of additional price increase is high. Now, if this breakout failed and we get this reversal, that's a condition, that's new information, and that's just changed the probability of how bullish we were. As long as we were above this support, this resistance turn support, we were bullish, right? The probability of us going higher was high. When this breakout failed, the probability shifted based on this condition that we got a failed breakout, and that has to make us change our positioning. And that's how it's important. You have to realize that the probabilities change based on new information, new data, and be constantly ready for it. Now in this case, we are not using Bayes' theorem. We don't really care much about the historical data, none of that stuff. But you need to have a basic idea of why conditional probabilities are important. A new condition, a breakout failed, changes everything. If you get a reversal candle at major levels, here, we just broke above this resistance, but then we got a reversal candle, right? The buyers could not keep the pressure, they gave up, and we closed with a hammer candle at resistance. Now, that hammer candle, because it's a resistance, just changed the probability of us being bullish. When we were coming into the resistance, we are bullish. But as soon as we got this reversal, now we have to the odds have shifted in the favor of bears. Another example of conditional probability is stocks sell off on good earnings. Let's say usually if you get good earnings, a stock rises. Okay, maybe it gaps up and it rises. Now, let's say in one of the days we got the stock to gap up on good earnings and then it sold off the entire market session. People are always confused, like, oh, there was good earnings. Why the hell is the stock selling off? What's going on? The markets are manipulated, blah, blah, blah. But what we can do is use that as information. The condition is that the stock sold off all day on good earnings. What does that tell us? That tells us that the sellers are strong, that the bears are in charge, and the probabilities are in favor of the bears. So now let's tie it back to why this is in Psychology and Mindset series. It's because you have to internalize these ideas, which are that probabilities in the markets are always adjusting based on price info. Probabilities in markets are always adjusting based on what's going on in the market. How do we know what's going on in the market? Is through price. So if a stock is bullish, but then it goes to a resistance and reverses hard, our probability of being bullish has changed now dramatically. Now we are more bearish. So our job as traders is to adjust our trades based on these changing probabilities. If you get a reversal, if you get a sign to get out of the trade, if the probabilities have changed based on new information, maybe it's FOMC, maybe it's CPI, maybe it's earnings, whatever it is, our job as traders is to account for these probabilities and change our trades based on that. Always think in terms of possibilities. There's a common adage, the common saying for traders in the markets. It says, strong ideas loosely held. The reason we say that is if you don't have a strong opinion, you will get whipsawed out of the trade. You will not be able to hold a trade. So you have to have a strong opinion until a new information comes. If a new information comes that asks you to change your opinion, then you have to let it go right away. So strong opinions loosely held. You do not get married to your opinions. You have strong opinions as long as the data favors it. As soon as the data becomes unfavorable, you let that opinion go and you adjust. That's it for this tutorial. I hope this will be helpful in seeing how we have to constantly analyze our decisions based on changing odds. Markets are not like life, and I know humans love to think in definitive terms, especially men. We like to think this is how things happen. But the world does not work in that way. The world works in probabilities, in possibilities, and you have to account for that. And you have to take the route. That's why I keep saying the path of least resistance, the most probable route, because we have to think in terms of probabilities. Sometimes the least probable route happens. You have to be prepared for that, and you have to account when that starts to happen. How do the probabilities change? All right, guys, if you have any questions, feel free to ask me in the chat, and good luck.